G'day guys, welcome to Year 7 NAPLAN Tips and Tricks, Part 6. If you haven't seen my other videos on Year 7 NAPLAN, I'll put them in the top right. Let's get into the video. Question 26. This table shows the length and width of 4 rectangles in centimeters. Which rectangle has a perimeter of 32 centimeters? Okay, so there's a few ways to find out the perimeter with the length and width. So you could do length plus width plus width. Length times 2 plus width times 2, or my personal favorite, as it's the shortest and easiest to remember, length plus width times 2. So that's what we're going to be doing to the rectangles with the length and the width. So if we write all that out, we can see that rectangle A is the answer. Question 27. The regular price of a shirt is $24.50. The shirt is on sale for 10% off the regular price. What is the sale price of the shirt? So, to find 10%, we're going to divide 24.50 by 10. And we know that we move the decimal point to the left one place. So, the decimal point goes here. So, 10% of 24.50 is 2.45. Now, we need to subtract that from 24.50 because it's not asking what is 10%. It's asking what is the actual price of the shirt now. So, if we subtract that, we get $22.05. So the answer is $22.05. Paul is playing a Guess My Number game. He gives these clues about his number. My number is a square number. My number is divisible by 2 and 9. My number has 2 digits. Okay, so we're going to start by writing out all the 2-digit square numbers. So, if you don't know, a square number is basically a number times itself. So 2 times 2 equals 4. So 4 is a square number. 4 times 4 equals 16. So 16 is a square number. And so on. So let's list those out. So these are all our 2-digit square numbers. Now, we need to see if they're divisible by 2 and 9. So let's draw a quick table. We can see that 36 is the only 2-digit prime number that is divisible by both 2 and 9. So Paul's number is 36. Question 29. Pears cost $4 per kilogram. Ben buys 4.15 kilograms of pears. How much does Ben pay for the pears? So, if pears cost $4 per kilogram, and Ben buys 4.15 kilograms of the pears, you would need to times 4.15 by the $4. And that equals $16.60. Question 30. Lucy enlarged her rectangular deck so that the length and the width were both tripled. How many times as large as the area of the original deck is the area of the new deck? Okay, so let's just draw out a rough drawing of our deck here. This is the length, and this is the width. Let's say the length is 1 meter, and the width is 3 meters. So the area of this would be 1 times 3, which is 3 meters squared. And if we triple both sides, 1 times 3 is 3 meters, and 3 times 3 is 9 meters. And the area of this would be 3 times 9, which is 27 meters squared. So we can see that we've gone from 3 meters squared to 27 meters squared. And 3 times 9 equals 27, so it's times by 9. Another way to think of it is that you triple one side, and then you triple the other side, which means it would be times 3, and then times 3 again, which means times by 9. Question 31. This year, Sam's age is both a prime number and a factor of 57. In 2 years' time, Sam's age will be a prime number again. What is Sam's age this year? Okay, so in case you don't know, a prime number is a number that's only divisible by 1 in itself. So 3 would be a prime number because its only factors are 1 and 3. 6, however, would not be a prime number because its factors are 1 and 6 and 2 and 3. His age is a factor of 57, So let's find the factors of 57. So 1 times 57. Does 2 go into 57? No. And we have 3 times 19. Does 4 go into it? No. 5? No. 6? No. 7? No. And you can keep going on forever, but you're not going to get any other factors. So these are our 4 factors of 57. We know that he can't be 1 because 1 is neither prime nor composite, which means it's not a prime number. And it also can't be 57 because if you add 2 to that, which is 59, 59 isn't a factor of 57. So that leaves us with these two numbers. So 3 plus 2 is 5, which is, yes, a prime number because it has no factors. So if we check the 19, 19 plus 2 is 21, but 21 has factors 7 and 3. Which means that Sam is 3 years old. Question 32. This object is made by cutting off each corner of a cube, as shown. How many edges does this object have? Okay, so we can see that instead of just the one vertice that combines the edges, we now have a 3-edge pattern. And because there were 8 vertices before, we are going to times the 3 edges they now have by the 8 vertices that there would be, which makes 24. And now we need to add the original edges. And because there are 12 edges on a cube, we'll find that the answer is 36 edges. So the answer is 36. Good luck on your test, guys.